Ever wondered how a computer could look at a picture and answer questions about it? Like, what's the dog doing? Or why is the sky red? That's the magic of visual question answering, or VQA, a field where AI systems learn to understand both images and language. But here's the twist. VQA isn't just about recognizing objects. It's about reasoning, connecting what you see with what you know. Imagine an AI looking at a kitchen photo and answering, "The pan is on the stove because it's where you cook." That's not just pattern recognition. It's understanding context, cause and effect, and even common sense. So how does this work? Researchers train AI models on massive datasets of images paired with questions and answers. For example, a model might see a cat and a question like, "What is the animal doing?" The AI must look at the image, process visual details, and generate a text answer. But here's the catch. It's not as simple as matching keywords. The AI has to interpret the scene, like figuring out that a cat sitting on a couch is relaxing, not just on the couch. The real challenge: teaching AI to think like humans. We don't just see a picture, we infer, deduce, and connect dots. But AI often relies on shortcuts. For instance, if a model sees a question about a dog, it might guess dog every time, even if the image shows a cat. It's like a toddler memorizing answers instead of understanding the rules. But this research is changing that. By creating benchmarks that test not just recognition but reasoning, scientists are pushing AI to go beyond memorization. Imagine a system that can explain why a ball rolls down a hill, or predict what happens if a door is left open. These aren't just cool tricks, they're steps toward AI that can understand the world, not just describe it. So the next time you see an AI answer a question about a photo, remember, it's not just seeing the image. It's trying to think about it, just like you do. And as this field evolves, who knows? Maybe one day, your AI will not only describe the picture, but also tell you why the sky is blue, or why the dog is chasing its tail. Thanks for watching. If you want to explore how AI learns to see and think, hit subscribe. And let me know in the comments, what's the weirdest question you've ever asked an AI? Back in 2015, AI was like a kid memorizing flashcards. It could guess answers based on patterns, but it didn't understand what it was seeing. For example, if a model saw a dog in a picture, it might just shout "playing," without knowing why. It was good at surface-level tasks, but clueless about context. Fast forward to 2023, and researchers hit a breakthrough with MMU, a massive multidiscipline multimodal benchmark. Think of it as the ultimate AI exam. It's not just about what's in this photo. It's about reasoning across science, art, history, and even complex puzzles. Imagine asking an AI, "Why did the inventor modify the engine?" while showing a technical diagram. The model has to combine visual clues, domain knowledge, and logic to answer. But here's the twist: even top AI models struggled. They aced simple questions, but froze on tricky interdisciplinary tasks. This isn't just a tech problem, it's a big reveal about AI's limits. Right now, AI is like a super-fast calculator. It can crunch numbers lightning fast, but it can't think like a human. It lacks that broad, flexible understanding we take for granted. Enter STARE, a new benchmark focused on spatial reasoning. Think of it as a puzzle challenge for AI. Instead of "What color is the car?" it asks, "If you rotate this cube 90 degrees, which face will be on top?" The goal? To test whether AI can simulate visual changes step by step, like how you mentally picture flipping a shape in your mind. Here's where it gets wild. STARE isolates spatial reasoning from other skills. For instance, it might show a 2D shape and ask, "What does it look like when folded into a cube?" Or present a tangram puzzle and ask, "Which piece fits here?" These tasks aren't just about recognition. They're about understanding how objects move, change, and interact in space. But here's the catch. Even with these challenges, AI still stumbles. One model might correctly identify a shape's rotation, but miss subtle details like color or size. Another might follow folding instructions literally, but fail to visualize the final 3D structure. It's like solving a maze by following a map, but getting lost when the path isn't clear. Why does this matter? Benchmarks like MMU and STARE aren't just tests, they're roadmaps. They show how far AI has come and where it still falls short. By isolating specific skills like spatial reasoning, researchers can pinpoint weaknesses and develop targeted improvements. Take this example, a video sequence showing a chair. The first 3 frames show the camera slowly moving to the right, revealing more of the chair. The question: which image fills the missing frame? Claude's reasoning sounds logical at first. The camera is moving right, so the next frame should show the chair from the farthest right angle. But here's the twist: the model completely misread the direction of the camera motion. It thought the camera was moving left, leading it to pick the wrong answer. This foundational error shows how even a tiny misunderstanding of spatial relationships can derail the whole process. Then there's GPT-4o's perspective problem. Imagine a top-down view of a room with a red arrow pointing toward a curved seating area. The task: what does the agent see from this viewpoint? GPT-4o assumed the arrow was pointing toward a curved area and selected an option that matched that guess. But the correct answer required understanding that the agent would actually be standing next to the curved seating, not looking into it. The model failed to translate the top-down view into the agent's real-world perspective, like trying to read a map, but forgetting which way is up. These errors aren't just random flukes. They highlight a bigger pattern. AI models struggle with temporal reasoning, understanding motion over time, and perspective shifting, seeing the world from another viewpoint. But here's the cool part. Researchers found a strong link between how well models do on synthetic tasks, like 2D, 3D transformations or CubeNet folding, and their performance on these real-world challenges. The better a model is at manipulating visual patterns in controlled experiments, the better it tends to handle messy, real-life scenarios. Interestingly, open-source models still lag behind their closed-source counterparts, but even they show improvement when given visual simulation tools. The takeaway: building AI that truly sees the world requires training it on both structured puzzles and real-world complexity. It's like teaching a child to recognize shapes, and then using those shapes to solve a jigsaw puzzle. So next time you watch a video or look at a map, remember, even the smartest AI is still learning how to see the world the way we do. And that's a journey worth watching. Thanks for watching. If you want more deep dives into AI's wiggles and wins, hit subscribe. Until next time, keep questioning what you see.